Hello, good morning, good afternoon, and welcome. I'm very pleased to be joined by Frank Wrobel. Frank is head of marketing and business development for the DACH region at Schneider Electric. And Schneider Electric are one of the platinum sponsors at World Electrolysis Congress, which is taking place in Dusseldorf next month, so 14th to 16th of March. So welcome, Frank. Thanks for joining us.
Hello to everybody. So happy to be with you.
So Frank, you've obviously Schneider Electric is a business with a lot of interest, I guess, now in hydrogen, but given the electric part, it's interesting to see a electric company involved in gas. So can you give us some background to how you've come into hydrogen and also having a look maybe at Schneider Electric's business as well?
Well, thank you first for this nice question, because this will explain a lot. I started my career in Schneider Electric, or in one of the subsidiaries which have been bought by Schneider Electric. And during my complete professional life, renewable energy was part of the day-to-day business. Either it was PV, or it was on the hydro side or on the wind side. So I started first to have a look at the hardware side on what the processes are needed. But at one moment of time, the higher the percentage of renewables get into a grid, there are other problems popping up, and we need to think about solutions for those problems. And the one we are talking a lot about these days in our region, in DACH region, is storage of energy for the use when there is no wind, when there is no sun, and also the management of load peaks, that we can better manage the load peaks and reduce the stress from the electrical grid. For both, hydrogen is a solution, and we are looking at this from a company perspective. Even though we're coming from the electronic side and the electrotechnic side, which is at the end of the day a big part of the electrolysis process and everything which goes after the electrolysis process.
Yeah, because I mean, how much is renewable, part of the energy grid or the energy mix now in the region that you cover?
Well, it's every year we can see the statistics, and in Germany these days, or last year, it was close to 50%, so 48% of the energy generated in Germany was renewable. And beyond that, the target which Germany set themselves is to go to 80% of renewable energy generation in 2030. Which is obviously an enormous increase in energy, which goes along, on the other hand side, with the enormous demand, which we will see on the industry and the private life.
Yeah, and therefore the role of hydrogen is to help balance that electricity.
Exactly. So what we need to make sure is to store the energy once the energy is there. So if we have heavy winds, or we have sunny times, so we store the energy and give it back to the grid later on, once there is no wind or less wind, less sun. This helps to have a resilient grid, and will for sure be one part of the solution of the energy dilemma we have. So this means the demand of energy goes up on the one hand side, but we have to reduce the CO2 emissions at the same moment of time.
Yeah, and that's obviously at a big system level in terms of the entire sort of the grid in Germany, but are there also opportunities, I guess, for hydrogen to also help with resilience for industry and for businesses in terms of the scale? Obviously, at World Electrolysis Congress, there's a lot of debates around centralized electrolysis and decentralized electrolysis, and certainly there seems to be opportunities at both scales. So what is some of the work that you're doing on that sort of different scale of electrolysis?
Well, as you just mentioned, so we have the grid side, which is let's say we all need on the private life but also on the professional life. But there is also the industrial processes, and then again there are mainly two processes on the industrial side which we need to have an eye on. The first one is there are parts of the industry which needs high temperature for transforming goods, like the steel industry or the glass industry. You can't just do with electrical energy. You need to have more power.
Yeah.
So therefore, and this we all know, hydrogen is one part of the solution. So this is one part of the story. The other part is that we have, for instance, the cement factories. They are producing a lot of CO2. And here hydrogen plays an important role in order to capture the CO2 created by the industrial process and to transform it to different chemical goods.
Mm-hmm. Okay. What sort of, e-fuels you mean, or other chemical goods in terms of syngases or?
Well, this can be chemical goods which can be used for e-fuels, but it can be used also in industrial processes. But yes, there is in energies and chemicals in this part of the industry, there will be a use for those.
In terms of the, Schneider Electric do a lot of work around balance of plants and also, obviously all around the electric side. And as I see it, electrolysis is built up of many sort of small units, so they scale, I guess, in parallel. And so what are some of the sort of challenges around providing the electrics for electrolysis, or the electronics for electrolysis?
No. Well, I would say the electric balance of plant or power supply units and so on, this is more a straightforward business. We are dealing since years and years with it. There's no big difference between other generations or energy distribution. So we need to provide energy for the industrial process.
Yeah.
So obviously you have to have a different architecture. The more, let's say, lines of electrolysis you have in parallel. So you have to split this. But in general, this is pretty state-of-the-art technology we can provide.
Yeah.
So there's no big risk for that.
Yeah. Okay. And in terms of some of the other what challenges do you see across the areas that you're working and the projects that you're working on?
The main challenges is what we need to do is to help our customers to optimize their efficiency of the complete process. So it means to make the most of the energy they are putting into the system. And obviously this does not work only with hardware. Hardware is a part of it, it's a facilitator, but we need to have software. So we're talking about software. What we need is to have a software which can drive the industrial process, but which helps also the customers at the end of the day to manage their assets, to know exactly when they have to do their maintenance stops. They also need to report what are maybe the CO2 footprint of their overall industrial process. And for this, we do have software solutions, which we call at Schneider Electric EcoStruxure, as a logo of this type of software types.
Okay, so is there like an energy management software system in terms of being able to get all the data and be able to optimize the industrial processes. And in terms of that, is that applicable also to creating microgrids and giving the opportunities to some of the industrial customers to island off the grid and consume and use energy?
Well, this is exactly on if we look at the ecosystem of our customer, and when they have in mind to make more use of their PV installation they have on the roof of their production. Obviously, at the end of the day, they have to decide what do I want to do with the energy I'm producing here. Yeah. Do I want to feed it back into my network inside in order not to feed it into the grid? This is one thing. Do I want to reduce the load peaks in order to save money from the energy bill of my grid provider? Or do I want even go beyond and say what you just mentioned? Do I want to create an island in case there is an energy shortage? Either it is on the gas side or on the energy side, and I still want to run my factory later on, maybe not at 100%, but maybe at 30%.
Yeah.
And for all this, we have solutions. And there's this, what you just mentioned, the microgrid. So we do have microgrid advisor and operators. We can even, let's say, make sure that the industrial process of our end users, not the electrolysis process, but the end user process will be managed by the software that we switch off automatically in case there is a shortage. Yeah. All those parts of the industry they don't need at that moment of time, which have been defined beforehand. Huh?
Yeah. I mean, I imagine that this is quite topical at the moment, given the impact of the energy crisis. We've seen, major industries had to shut down or reduce because of the gas peak prices, led on by the political situation in Ukraine. So I can imagine that there is a lot of appetite for this in terms of building resilience for businesses, and also, I guess, real value in taking that volatility out their businesses, so that they can, when we first saw that with the PPA market in renewable electricity, there was demand to pay for slightly higher electricity, but because you were guaranteeing the flow, and you were creating a much more resilient business that was less risk involved. That's a sense, essentially, and less risk means less cost for businesses. So yeah,
and we do have to have in mind also that CO2 emissions are getting more and more expensive in future. Mm-hmm. So this is not only resilience, but it's also a question on, let's say, at the end of the day, there are real savings for the customer once they go for, let's say, green hydrogen, and a process which supports the reduction of CO2.
Yeah, it's great. It's fascinating. So excellent. Well, many thanks for sharing your thoughts today. It's been interesting to chat to you. We obviously look forward to catching up with all your colleagues who will be at World Electrolysis Congress. It's certainly a white hot area for development, for innovation. So well done on the work you're doing, and we look forward to supporting Schneider Electric and providing solutions both to the climate crisis, but also building resilience and helping businesses cope with volatility. So many thanks, Frank. Take care, and look forward to meeting you in the future.
Thank you. It was a pleasure to be with you.
Thank you. Bye.